In this video, we will study about the heat treatment of steel. So let us start with an experiment here. So here I am taking a different types of steel, and measuring its hardness. So you are using a hardness, Rockwell test for hardness, and I'm measuring the percentage of carbon in each, and then I will look in the microstructure and the various heat treatment process. Various heat treatment process. First, I am taking the first steel, that is A. I am doing a Rockwell hardness test about the Rockwell hardness test means I am taking a steel specimen and I am trying to make an indentation. Okay, and by measuring the indentation, so that means I can measure the depth and also sorry, I can measure the depth. Let us call it H and let it be this be D. Okay, this is D. And measuring the depth and the size, diameter of the indentation, I can find the hardness of the material. Okay, this is the Rockwell hardness test. So that means I am doing a this experiment on different steel, that is A, B, C, D, and and I'm measuring the hardness based on the Rockwell hardness test. There is a number. So I found that the hardness was different: 15, 30, 45, 55, 65. So what may be the reason for that? The different hardness. So the hardness can increase depending upon the percentage of carbon in the steel. That means as the carbon increases, the hardness increases, but the brittleness will also increase. So I just measured the carbon content, but surprisingly, I've found that the weight percentage is only zero point 0.8. Okay. Carbon content is only 0.8%. That means there is no change in the percentage. Then I inspected the microstructure. So I found that the first one had got a coarse pearlite structure. We have seen what is pearlite in iron carbon equilibrium diagram. The second structure was fine pearlite. Second structure had fine pearlite. The structure had a microstructure called bainite, and the fourth one had a structure that is called tempered martensite, and the fourth one had martensite. Okay. So that means the microstructure of these steels were different. So our focus on this chapter is how we are getting this different microstructure, which has got different properties. So this can be achieved using heat treatment process. The first heat treatment process is called annealing. It's called annealing. Second heat treatment process is called, that is, normalizing. And the third process, this is called Ose tempering. Okay, Ose tempering. And fourth process is called tempering. And the martensite formation process is called quenching. So we have already studied about iron carbon equilibrium diagram, also TTT diagram. What is the relationship between transformation, temperature, and time? So, so let us discuss about these various heat treatment processes. So before that, let us draw the iron carbon equilibrium diagram once more. That means I am taking only the eutectoid reaction. So eutectoid reaction here. Here this is 910 degrees Celsius. This is eutectoid reaction, of course, at 725 degrees Celsius. That means here it is gamma plus Fe3C. It is gamma. This is alpha plus gamma. This is alpha. And here you have alpha plus Fe3C. So that means here you have 6.67 percentage carbon, or you have Fe3C, that is cementite. Here you have pure iron. This is percentage iron, percentage carbon, and this is 0.8 percentage, and this is 0.02 percentage. So this was the eutectoid reaction. So in eutectoid reaction, an austenate is just converted to alpha plus Fe3. This is a phase transformation process. Okay. So so far, uh, you know that this is a phase transformation process. So in iron carbon equilibrium diagram, we did not take into account the effect of time. Okay. So see, this transformation will occur if you allow infinitely long time. Okay, infinitely long time. It is cooled extremely slowly, then this transformation easily occurs. But if you increase the transformation time, so that means if you cool it slowly and cool it fastly, then you will get a different microstructure. You will study about the different microstructure here. And this process is called the heat treatment process. So if you allow sufficient time, then you will get a structure like this. Okay, you will get a structure like this. This is alternate lamellar structure of alpha and Fe3C. This is the difference. Okay, now let us discuss about the various heat treatment process. Various heat treatment process. Okay. So what do you mean by heat treatment? So heat treatment basically is heating a material, heating a material to a temperature, to a temperature, holding it at that temperature, at that temperature for a period of time, period of time followed by cooling at a specified rate, cooling at a specified rate is called heat treatment. Is called heat treatment. That means by cooling at a different rates, you will get different microstructure. So let us draw a graph showing that. So here you can see the time, and here you have the temperature. So that means first heat treatment is heating to a particular temperature. For the in case of steel, we are heating the temperature above the eutectoid temperature, that is above the 725 degrees Celsius, holding it for a period of time, and then it is so so you can cool it at different rates. Okay, so you can cool it at this rate, and then you can have cool it at a different rate, that is 2, and then you can cool it at a different rate, that is 3. So that means again I cool it at different rate and holding it for a particular temperature, and then again cooling it. Is what I am doing here. Then there is another process. See, I am suddenly cooling it. It can be called process 5. And then another process is after suddenly cooling, again I will increase the temperature up to here and then hold it for a particular amount of period of time and then again cool it. So this is called the process 4. So let us look at what are these different processes. So in the earlier example, in the earlier experiment, I have discussed about various processes, that is annealing. So this corresponds to 1, and this corresponds, normalizing corresponds to 2, and this corresponds to 3, and this corresponds to 5, and this corresponds to 4. So these are the different processes. We will study about these different processes. Okay, so let us look at the process. The first one is annealing. You can see that that is a slow cooling. That is slow cooling, and you will get coarse perlite here. You will get coarse perlite. Okay. The slow cooling means it is also called furnace cooling. Furnace cooling means this steel, if it is heated in a furnace, as the furnace cools, the steel will also get cooled. So that will be an extremely slow process. So you can increase the cooling process. That is a process that is called normalizing. In normalizing, you have a faster cooling. That means you take the steel outside and allow it to cool in air. This is called air cooling. Okay, this is called air cooling. Here you will get fine perlite. Here you have a structure that is fine perlite. And the third process is Ose tempering. Ose tempering. So this is a process called interrupted quench. Interrupted quench. That means you can see here 3. So that means you're cooling fastly, then holding at a particular temperature, you're holding at a period of time, then again cooling. Okay, you will get a bayonet structure. And the fourth process is called first. First, let us see the quenching process. Then we will discuss about tempering. Then you have the quenching process. That means this is very fast cooling. Okay, you have very fast cooling. So that is called quenching. That means you are placing that steel in water and allow it to cool very fast. The structure you are getting is called martensite. We will see what it is, martensite. And the fourth process is called tempering. Okay, in the figure you can see that, say this 4, that means you are quenching it to get the martensite, again heating to a particular temperature, holding it for a period of time, then cooling. So that is heat after quench, heat after quenching. So here you will get a structure that is called tempered martensite. Tempered martensite. Okay. So this is all about heat treatment. For we will discuss about the TTT diagram of eutectoid steel in the next lecture. So these are the different heat treatment process that we need to study.